Hi folks, Pacer Don here with a quick response to Cherno's request for doing collision in a different way. I learned how to do collision by knowing if two tiles were overlapping. If the area of one tile was within the area of another tile, any part was within any part of the area of another tile, they had to collision. And you do that through the boundary of the tile, and I'll show you how to do that. First, make a copy of your current project because we don't want to mess up what's being done in the current series. So right-click on your project, copy, right-click again and paste. Call it whatever you want, that's fine. Leave minus copy of array. Now to do this check, we're going to use a new class, and we're going to create that class under level. So go to level and do new class. And we're going to call this class boundary because we're going to be checking the boundaries of our tiles. And a boundary of a tile is defined by the corner pins, so our properties will be corner pins. And be careful, watch your Y's and your X's because it's very easy to mix them up, and you'll try to be figuring out why you're still going through walls or whatever. It's because you put an X where a Y belongs or a Y where an X belongs or something like that. And we'll do our constructor where it's to assign our properties. Okay. Make sure your X's and make sure your X's and your Y's line up. Now, how do we check this? Well, again, like I said, the way I do collision or learn how to do collision is to check if two tiles overlap. So let's call our method overlaps. And we're going to be checking two boundaries. So either we could pass in the four corner pins, or we just make it easier and just pass in a new boundary object. Go with that and call it our target. It's more readable this way too anyway. So the easiest way to tell if two tiles overlap is to prove they don't overlap. Assume they overlap and then prove they don't overlap. So let's assume they do overlap by returning true. And now let's disprove this. Oh, we got to return a Boolean actually. Forgot to do that. This returns a Boolean, true or false. And how do we tell if two tiles overlap? Well, I've actually diagrammed it here. Let's say this is our tile, this is a target tile. If the lower boundary of our target tile is above the upper boundary of our tile, if the y1 is less than our y0, they will never overlap. Same with the x's. If the left side of our target tile is to the right of the right side of our tile, they will never overlap. Same here, same there. So this is what we'll implement in our code. So first we'll check the target tile. If the target tile y1 is less than our y0, they don't overlap. What's another condition for not overlapping? Well, if the target x0 is greater than our x1. Another condition, if the y0, if the top of the target is below our bottom, if y0 is, target y0 is greater than our y1. And the final condition is if the right side of the target is to the left of our left side, or if x1 is less than, target x1 is less than our x0. If any of those conditions are true, they don't overlap, so return false. Otherwise, they do overlap, return true. And that's it for that class. Now to implement this, we'll do that in our mob, which is where we have our mob class, which is we have our collision method. Go to the collision method there, and we'll just comment out the current code, we'll leave it there for reference. So this code is going to be requiring conversion from pixel coordinates to tile coordinates, and to do that you either multiply or divide by your tile sizes. Rather than putting a 16 in, hard coding a 16 in there, I like to use variables, and it's also more readable that way. So for the purposes of this demonstration, I'm just going to use variables. So our tile size is 16. Our standard tile size for this project is 16. We also need to know our player size. The player size for this current project is a 4 tile player, so we change this 16 times 2, 32. So times 2, or 32. That's for a 4 tile player. If you happen to just have a 1 tile player, then just make it equal to tile size. It's that easy. So whichever one fits your build, choose whatever is applicable to you. If you're not sure, you probably are doing the 4 tile. If you're doing the big king Cherno, you need the 4 tile. How about that? So what we need to do now is we know we need to get our boundary of the tile we're moving to, because we're going to be comparing that against the tiles around us to see if it overlaps any of them. So let's go ahead and create a new boundary object of where we're moving to. And we're moving to where? Our x coordinate plus xa and our y coordinate plus ya. And since we're defining a new boundary, we're also going to define the corner pins, so x plus xa plus and our player size. But we're not using our true player size. We don't go 1 to 32. We actually go 0 to 32, so you have to use player size minus 1 here. Same for y. And also we have to import our boundary class so it knows to use it. And that's it. Now we've got the boundary set for where we're moving to. We just basically need to check the tiles around us to see if we overlap it. And you could use these and determine what tiles you're going to march on top of. I just find it easier just to check them all because there's only 8 tiles around you. And we do that by checking the tiles that are a row above us, which is y divided by tile size. Actually, this might be readable if I make more variables here too. So this will give us the x and y tile coordinates of the current tile. So for our check, we want to do a row above us, while it's less than or equal to a row below us, increment our y. And also we're going to check for out of bounds, level dot height, then continue, just skip everything and just keep going. Go back, do your next y. Height is not visible because it's not public, so just click there to make it public. It'll open up your level class and you'll see it makes it public. Click back to your mob to do and then we'll do the same for x. xp is equal to this tile x minus 1, the column to the left of us, while xp is less than or equal to x, the column to the right of us, increment our xp. And again, check boundaries, or check out of bounds. Level dot. This time we're doing level dot width. Continue. And like the height, it's also private. You're going to have to make it public. And your level class. All right. And now we do our check, but we're only concerned with tiles that block us. So first off, we want to check and make sure that the tile we're checking, is that going to block us? So otherwise, don't bother checking. So if level.get tile xp yp solid, if it's solid, then see if we overlap. Check for overlap. First, to do that, we get the boundary of the tile we're on. And since xp and yp are tile coordinates, we need to convert those to pixel coordinates, multiply them by tile size. And next, also add the size of the tile for your bottom boundary and right boundary. Don't forget to subtract your 1 because we're going 0 to 31, or 0 to 16, Z15, not 1 to 16. So now we've created the boundary for the square we're checking, or the tile we're checking. Now let's check and see if our destination overlaps this tile. And we do that by if, and this is why I love descriptive variables. If player destination overlaps tile boundary, then solid equals true. And that's it. That's all the code we need. So they're setting solid false by default. We only set it to true if we are overlapping, if our destination overlaps a tile that blocks us. And our XPs and YPs should be okay. Return solid. Let's give it a try, see if it works. Probably won't. I always mess up the first try. Oh, look at that, it worked. And there you go. So now your guy gets blocked, and he's using boundaries. And you get blocked by any tile, not just the current tiles. Now, how do you check this to The other question was, how do you keep moving? Come up here, and instead of checking both coordinates at the same time, check them one at a time and increment them one at a time. So just do your X first, and then do your Y, and only increment those if they are valid. Run your sample again, and now if you're moving diagonal, well, actually I messed that up, didn't I? I got X plus XA instead of Y plus YA down here. Be careful, like I said, easy to mess that up. Now let's try that. So now if you're moving diagonally, you'll keep sliding, you'll keep going in the direction you still can go. And that's it. That is implementing collision with boundaries. Hope you enjoyed it. Bye-bye.